Hi, we're the Practicum team working with the Bay Foundation. And this year we focused on marine vegetation restoration. First of all, why do we even care about marine vegetation? Well, we'll be focusing on eelgrass and kelp, and both of which are extremely productive places in the ocean. However, because they're hidden underwater, it's often difficult for us to see how magnificent and how important they are to our economy, our culture, and our environment. And they provide a number of ecosystem services from improving water quality, protecting from storm and erosion, providing a nursery for marine life, a habitat for high biodiversity and thousands of marine animals, and for sequestering carbon and nutrient cycling. Unfortunately, because of human activity, we are threatening and degrading these eelgrass and kelp ecosystems, both on the local scale and on the global scale. So locally, like overfishing, boating and trawling, runoff pollution, coastal development, and on the global scale, things like increased water temperature and sea level rise associated with climate change add to these existing local impacts. Our client, the Bay Foundation, has been working on their eelgrass subtidal transplantation in the Santa Monica Bay, which is aimed to restore a rare species of eelgrass known as Zostera pacifica. And because there's little knowledge on Zostera pacifica since it's so hard to study, our Practicum team has focused on overcoming the associated barriers with this and is trying to support the Bay Foundation with their eelgrass restoration project.
In order to help aid Bay Foundation with these barriers, we came up with these 3 guiding research questions. The first being, what attributes characterize a successful eelgrass transplantation project? The second one, we focused on what criteria can we use to identify some potential eelgrass transplantation zones within the Santa Monica Bay? And the third being, where are these priority zones located within the Santa Monica Bay?
So in order to answer some of these research questions, we decided to focus on making 3 deliverables over the course of this year. The first of which was creating a suitability map to indicate the best places to transplant eelgrass in the Santa Monica Bay. And the reason we did this is because we wanted to create an interactive tool that was more intuitive than just logging on to the ArcMap software on your computer and make it accessible online. So the image here shows the default map with pre-selected layers to show a binary suitability, and we included data from the following parameters. So we used kelp locations. You don't want your eelgrass too close to kelp, but you want it close enough so that the biodiversity of the kelp can transfer over to the eelgrass. You don't want to plant it on rocky substrate, and you do want to plant eelgrass on sandy substrate. We also took into account bathymetry, contour lines, and depth, as well as nitrogen values and light exposure and wave exposure. So as you can see, the green areas on our map indicate areas of varying suitability. For example, sandy substrate and low wave exposure both are suitable criteria. So when those two overlap on top of each other, they create a darker green. And then the purple areas indicate areas of non-suitability. So for example, if there was a sewage outflow with a lot of nutrients that would nutrient burn young eelgrass, or if there was a kelp forest or rocky substrate, eelgrass would not be able to grow there. From this map and our calculations, we estimated that if we were able to plant eelgrass in all of the suitable zones in the Santa Monica Bay, we would be able to sequester between 1 and 5 million grams of carbon every year, which is really exciting. And so the final version of this map is going to be uploaded on our website. It'll be fully interactive. You can toggle the layers on or off, zoom in, zoom out, click areas to get information about the layers. And as I mentioned before, so we have multiple suitability criteria, and if you overlap a couple of those criteria over each other, the green that results will be darker. So the darker green indicates more suitability, whereas the lighter green represents less suitability. And the same goes for unsuitable locations, but they're marked in purple. So if anywhere you see purple, that means that area is not suitable for eelgrass growth. And it's actually quite interesting. These 2 red dots are locations where the Bay Foundation was considering doing an eelgrass transplant, but our map indicates that that southern point is actually not going to be in a suitable zone, so they concluded to move that point a little bit up north into that green zone. So we can already see positive effects of the work we've done, which is very exciting.
So the second deliverable our team created was a tool that consisted of a 3-star ranking system that is aimed to quantify the success of past eelgrass restoration projects or any future restorations. This was created after performing an extensive meta-analysis where our team was able to create a scheme that consists of 3 attributes, which can be seen here in our 3-star chart. It consisted of species diversity and composition, enhanced vegetation, and physical conditions. Within these 3 attributes, we also have 3 to 4 sub-factors that account for differences in each restoration site.
So ultimately, we found that these 3 attributes were commonly a way for the majority of these eelgrass restorations to communicate kind of summary of the general health and functionality of the ecosystem. We ultimately assessed each of these attributes based on its measurable components that Vanessa mentioned earlier. So each of our restorations has its own pinwheel visual, like the example that you see on the right, which portrays our evaluation of its success. On the left, you can see our reference data, which reflects the ranges of success that we collected from our meta-analysis. And here you can see the colors of the pinwheel on the right correspond to the colors of the chart on the left. So basically in this example, the 2 orange shaded pieces denote that the article received a ranking of 2 out of the possible 3 stars. This is based on the outcome of the example restoration as compared to the reference data. Then as you move to the green section, you see the same relationship between the 4 shaded pieces and the chart, and then the same with the blue. So in this example, the resulting evaluation might indicate something like the particular restoration may need to focus more efforts towards the attribute 1, which is species diversity and composition.
So for our last deliverable, we created a short scientific communication documentary that focuses on marine vegetation restoration and its role in climate change mitigation. We wanted to connect eelgrass and kelp to us and how the services they provide are essential in maintaining the way we live. Also in our documentary, we wanted to highlight the Bay Foundation's current Santa Monica Bay restoration project, especially how their 2 projects restoring kelp and eelgrass can create synergistic impacts. And then lastly, we hope to put the Bay Foundation's work in a global context that can be used in the future as an educational tool for their stakeholders in the community.
I remember diving down and seeing the expansiveness and the diversity associated with the habitat, and I was taken away. It's definitely a really intriguing and enthralling habitat that once you're there, you're like, gosh, this is incredible.
So this is our Practicum team. We've had a really great time working together over the last year, and we wanted to thank y'all for joining in today. The link to our full documentary, along with the supplementary information and deliverables, will be on the IoES website later this week.